So hello everyone and I welcome you all to the Rankplus JEE English. So how are you? आज हम करने वाले हैं. Today we are going to solve numericals related to the moving charges and magnetism. This chapter is very important, and in this session I'm not only going to solve the previous year questions, but I'll be decoding the questions pattern, and I'll also be decoding that what topics are examiners favorite and what are the formulas from where you will be getting the questions directly. So let's begin this lecture, but before starting you have to join our Telegram group as well, because on this Telegram group you will be getting the updates for your exams, plus you will be getting the DPP, daily practice papers, because these papers are very important. Because merely if you are watching my videos or you are watching any one shot in this universe, it will not gonna to help you to clear your JEE exam. To clear the JEE exam, you must do your practice, right? And for doing that practice, you must solve these practice papers, because these are being selected by me. So do join our Telegram group. The link is in the description, plus it's in the live chat. Okay, I think that it's missing from the live chat. The team will add that, but certainly it will be there in the description. Okay, and the next important factor is that there is a very special gift from Rankplus to all these students who are preparing for JEE 2025, and that gift is the playlist which we are giving to you for your JEE PYQs sessions, right? So it's a basically playlist which will help you to score more marks and will get you a more percentile. So students, please subscribe to that playlist as well and watch all my previous lectures also. Okay, now without wasting time, let me begin our lecture based on moving charges and magnetism. So if we'll talk about moving charges and magnetism, I have already taken the formula revision session on this YouTube channel. It was only for 30 minutes and I have covered all the important patterns which are coming. And in this video, I'm going to show you that based on those formulas, you can solve any previous year questions, right? And you know that why previous year questions are very important, because it basically tells us that what are the topics, what are the formulas, and what is the examiner mindset when they are designing the real exam paper. But the problem is that many of the students, I have felt that in this recent December time or the January time, they used to solve multiple mock test papers, and these mock tests are basically not at par with the real JEE exam, and they feel that they are underprepared, or sometimes they feel that they are over prepared. But the real exam paper looks like the previous year questions, right? Because these are the questions which we have taken directly from the paper, so you must have to solve these previous year papers. So in this moving charges and magnetism, basically we deals with what? We deals with magnetic field. We deals with magnetic field, and in how many conditions you need to find out the magnetic field? We need to find out the magnetic field due to a straight wire, right? If a wire current I is flowing through this wire, and at r distance, you need to find out the magnetic field. Through a circular coil, we need to find out the magnetic field. In a solenoid, we need to find out the magnetic field. If a charge is moving with a velocity, then we have to find out the magnetic field, right? So there are some conditions, there are some patterns only which you will be getting a question from this part, right? Magnetic field. It is not a random question which will be coming in your exam. It's not like they will be asking you that you have to find a magnetic field at this angle, right? They won't be asking you. I haven't seen that question, right? So the next part is in JEE Mains, you won't see those questions, right? Next one is the magnetic force. In the magnetic force, you will see that either there will be an individual charge, for an individual charge the force will be QV cross B, or there will be a current carrying conductor, and if there is a current carrying conductor, you can consider that the force is equals to Bill sin theta. force is equals to Bill sine theta. Okay, so magnetic field is there, magnetic force is there, and then we will go for the galvanometer as well. So galvanometer concept, cyclotron concept, we will see that what will happen that when a charged particle is moving in an electrical or magnetic field. These are the types of questions which you will see in this chapter. Okay, now let's start the real paper. This question is from JEE 2021. Let's solve this question. I'm giving you a timer. Do you want the timer? So Lucky World JEE, hi, good evening. Bunny V, good evening. And booster series, which booster series, Abhinav Kumar, you are asking for? Lucky World JEE, Bunny. So Happy New Year. Yes, Happy New Year in advance. And what is your resolution for JEE 2025? Tell me, what is your resolution in JEE 2025? I have seen my students that they are writing some quotes. They are writing some quotes on their registers. So what is your favorite quote? Tell me. Solve this question. I'm giving you the timer as well. Let me insert the timer. Then I won't be giving you much time. So let me put a timer here. I'm giving you 1 minute only. Okay. And if you want, at any moment of time, if you want some hint, you want the formulas, please do let me know. Because there are so many questions in moving charges and magnetism. If you know the formula, you can easily solve it, right? And there are some conceptual question that if you know, then you know. Otherwise, you have to be very, very you will be stuck and you won't be able to solve that. So 34 seconds is there. In this, they are asking the magnetic field at 2 points on the axis of a circular coil at a distance of 0.5 meter and 0.2 meter from the center are in the ratio 8:1. The radii of the coil is, okay, we have our radius. This is the x distance, right? Has anyone give me the correct answer? Abhinav, Lucky, Bunny. Arey, do tell me. Please be active. Light up the chat section with your fire emojis. Show me the energy. New year is coming, right? So, if I want to find out the magnetic field at this point is P at a distance x, and a current I is flowing through this wire, I can say that magnetic field will be equals to mu naught I r square divided by 2 x square plus r square 3 by 2, right? This is the formula, and I hope that you all know this formula, right? Now, if I need to find out the radius, which is this, right? So, according to the question, we have been provided by a data that B1 by B2, the magnetic field when the x value is 0.05 meter and when the x value is 0.2 meter is given to us. Then I can do one thing. If I'll be taking that the current will remain same, the radius will remain same. If I need to use the ratio, I can use one thing, that B is inversely proportional to x square plus r square 3 by 2, right? Right? That magnetic field is proportional to this one. So right here, I'm considering the x1 here. I'm considering the x1 is equals to 0.05 meter and x2 as 0.2 meter. So you can replace it here that it's 0.05 square plus r square power 3 by 2. And here you can use 0.02 square plus r square 3 by 2. It's 8:1, right? If you take the cube root, you will get 2 by 1 is equals to 0.02. I'll take the square also. Square 4. That will become 4. So 4 by 1 is equals to 0. Square plus r square 0.05 square plus r square. Okay, now you have to solve this to get your answer. If I'll multiply this thing, I'll get 4 multiplied by 0.05 square plus 4r square is equals to 0.02 square plus r square. R square is equals to 0.002. It's 02. It's 0.02 square minus 4 0.05 square. And r square, r basically under root 0.02 square minus 4 0.05 square divided by 3. Now solve this. And tell me what is the answer coming. 0.1. There is calculation, but let me use my scientific calculator. You have to do on your own. 0.02 square minus 4 multiplied by 0.05 square divided by 3. Wait. What answer you are getting? 0.02 square minus. Array, it was 0.2. It was 0.2, right? It's 0.2. 0.2 square. It's 0.2. Point 1. So it's coming to be 0.1 meter. Are you getting this answer? Nithila SR? Yes, this is the correct answer. Where are you from, Nithila? Nithila SR, from where are you from? Now let's move to the next question. So the correct answer for this is 0.1 meter. Okay. There is some calculation, but you have to do this. Okay, now let's move to the next question. This question is from JEE 2021. In this, we have been provided by three charges. One is the proton, neutron, and the alpha particle, and they are moving with this same momentum in a uniform magnetic field. The ratio of the magnetic forces acting on them is, and their speed is in the ratio. So basically, we have to find out two ratios here. First one about the magnetic forces. That means they are asking us F1 is to F2 is to F3. And also they are asking for their speed for V1, V2, V3. Right? For this you have proton, deuteron, and an alpha particle. And here also we are having different particles. So what must be our approach? And if you see the previous year questions, no matter that which year's previous year question you are solving, you will be finding at least one question will be there based on the similar situation, that you will be provided with multiple charges. Their masses will be either their masses will be unequal, their forces will be unequal or the equal, their speed will be equal or unequal. Means there will be some conditions, right? And you need to solve it. It might come in the magnetic field, it might come in the electric field. So there are multiple situations, but the pattern will remain same. In these types of question, whenever we have to do the comparison basically happens when we know about the charges, right? So I'm having three particles here. So let me consider that what makes them separate. So if I'm having a proton, the number one, let me take the serial number here. So I'm taking the proton here. And the next one is the deuteron. Do you know what is the deuteron? I hope that you know that there is a water, normal water is H2O. This is normal water. And if you replace this water with D2O, this becomes a heavy water. Right? So hydrogen have multiple isotopes. One is the protium, the another one is the deuterium, right? Do you know that? One is the protium, the another one is the deuterium. So here 1,1H, this is known as proton. Then 2,1H, this is known as deuterium. So here we have to keep the charge, and here we have to keep the masses. And there is another one, tritium. Because we are not here solving the JEE previous year questions, we are here to break down the pattern. We are here to break down the important types of questions which will come in your exam. We are here to break out the important topics which will be coming in your exam, right? So it's not just about the question, it's about the topic, it's about the pattern which might come again. So we have particles, protons, deuteron. We have proton, deuteron, and the alpha particle, right? The charge here, you can keep this E, and here the charge is 2E, right? For the masses, I'll keep this mass as mass of proton. This is mass of proton, twice of mass of proton, and this is 4 mass of proton. Are you getting it? So will you solve 100 question today? No, I'll not be solving the 100 question. I'll be providing, like, I'll be solving around 30 to 40 questions, and the rest will be homework for you. I'll be providing you the assignment. I have chosen the important questions, the important patterns, so that when I'm solving these 30-40 questions, it will cover almost all the possible patterns, right? So let's solve this question first. This is a table which you must know and which is required to solve this. Okay. Now, ratio of magnetic forces acting on them is, you need to find out that what is the ratio of the magnetic forces. We know that force is equals to Q VB sine theta I'll be taking. And if momentums are same, so P is equals to mv, right? If momentums are same, can I replace this velocity with P by m? Because here the masses are different, right? Here the masses are different, so I can replace this with qvb, qvb, qp, qp b divided by m, qpb divided by m, right? Momentum and magnetic field is similar. When momentum and magnetic field is similar, then I can say that force is proportional to q by m, right? And now we can find out that if I need to find out f1 is to f2 is to f3, q is e by m, I'll considering e by 2 mp. Okay. Tell me what will be the ratio here. Tell me what is the ratio here. You have to multiply it by 2, right? So the forces ratio will be 2 is to 1 is to 1, right? And when the force ratio is 2 is to 1 is to 1, I'll not be solving it for the velocity. Why? Because I got my answer, right? And I have to like, there should not be the insecurity about the answer which you are finding, because even if you find out the velocity, you will be getting this one, right? But if you get another type of questions, then your force must be the wrong one, right? So if I am getting my force and which is matching with my answer, and there is only one option available here, that is 2 is to 1 is to 1, right? So I'll be marking this and moving forward. I won't be giving much time to this question, because time is the ultimate thing what you have in your exam. If you have more time, then you will be able to solve more questions, right? And ultimately in the last few days we will be seeing that how to approach the paper, how just by observing some questions we can get the correct answer. These tricks won't be applying for all the questions, but certainly it will improve your at least 8 to 12 marks. This is my guarantee. I'll take a separate session for that. Now let's move to the another question. Vijay Roshan, is it clear, my dear? Do you want me to solve that? Okay, he is saying that, sir, please solve it. So we will solve it. See, if I need to find out the velocity is here, momentum is same, so I can say that velocity is proportional to 1 by m, right? When the velocity is proportional to 1 by m, you can use v1 divided by v2 divided by v3 is equals to 1 upon like I'll write here 1 divided by 1, 1 divided by 2, 1 divided by 4, right? Multiply this by 4, you'll be getting 4 is to 2 is to 1. So this will be my answer, right? I told you that either I'll be getting this one or my force must be wrong. Now let's move to the another question. This question is from JEE Mains 2021. A charge Q is moving dl distance in the magnetism field B. Find the value of work done by B. Tell me that what is the value of work done here? Clear, Vijay Roshan? Tell me what is the value of work done? It's a very simple question. It's a very, very simple question. Why? Tell me. What is the work done by the magnetic field? When a charge is moving dl distance in the magnetic field, will there be any work? Tell me, will there be any work? Okay, I'm getting the answer. 0. Vijay Roshan is saying 0. Yes, it's 0. There will be no work because it will be perpendicular, right? Motion will be perpendicular. Now, very simple question. And you will see that the examiner is very creative in asking the questions related to the circular magnetic field, the straight line magnetic field, or the semicircular. And you will see the creativity of the examiner, just like here. Look at the creativity level. Here, the examiner is saying the data hairpin like shape, as shown in the figure, is made by bending a long current carrying conductor. What is the magnitude of a magnetic field at this point P? Okay, which lies at the center of the semicircle. Okay, now I am giving you 1 minute to get the correct answer, and this question pattern is very, very important, and you will see the creativity what JEE examiners are showing us, right? And there is only one method which I tell to my student, is that you have to follow my approach. This is known as Manoj Kumar sir approach, right? Don't see the picture, because if you see the picture, the question seems to be very difficult. Divide the question into multiple parts. Do not look at the picture. See the pixels, what making this picture. In this picture, if I'll see, I am able to see 3 things. Are you able to see 3 things in this picture? The first one is the wire from which, the first one is a straight wire from which a current is moving. The second one is a semicircle. And the third one is another wire. So I am telling you that I am looking at this picture. I am able to divide this picture into 3 pixels, because these are the parts which is ultimately creating this picture. So I am seeing this first part, I am seeing this second part, I am seeing this third part. Are you able to see these 3 parts, right? And if you are able to see this these 3 parts, you have to find out the magnetic field at this point due to this. What will be the direction of the magnetic field? It's the inside. What will be the direction of magnetic field? It's inside. And what is the magnetic field due to this? This magnetic field is inside, right? Due to this, magnetic field is inside. Due to this, magnetic field is inside. Due to this, magnetic field is inside. Then I am getting that ultimately I have to add all these 3 pixels to get my answer, right? First of all, I have to calculate the magnetic field due to this wire, and then this wire, and this due to this semicircle, and I have to add. So the negative sign will not be there. So my option number, this and this, won't be my answer. How many of you are able to understand that these won't be my answer? Tell me. Are you able to get that? That how I'm telling you that these won't be my answers, right? Now, sir, I have what you are asking, sir. I have completed Kameksh, sir. I have completed 70% of the portion, is it possible to get above 90%? Still there is 1 month left. Your exam will be going to start from, I think that from 24th of January. So today is the day from like, even if I am thinking that today is the day when you are starting, and 70% is completed, 30% can be completed in 10 to 15 days. It won't take much time, right? If you will be providing the extra effort to complete that. And keep a calendar with you, go and purchase a new calendar and mark that you have to do it. Do you know that why IITians are getting a very high package and relative to the persons who are getting a college degree from a B grade or a C grade college? Because they are the men of their words. If they have to do it, they will do it. I have created, I would be saying, it is better to say that I have created multiple IITians, and I have seen a spark in them, that if I have told them that you have to solve this, they will be coming in the next class asking me the doubt, sir, I have completed this and I have doubt on this question and this question and this question. And I have seen super intelligent students, but they won't be asking me the doubts. They are like that, yes, they will do that, but certainly they won't be. Why? Because they are not putting the extra efforts. You know that hard work beat talents if talent fails to work hard. This is what happens today. And some of my students are also getting brain rot. What is brain rot? That they are addicted with the shorts, they are addicted with the Instagrams, and they are spending much time on their Instagrams. Their brain basically feels very tired when they started doing the numericals. And they say that, sir, I know that how to solve it, but I'm not getting the motivation from inside that to solve this. So if that is the problem, you have to think that at least for these 1 month, if you skip your Instagram, YouTube shorts, then it will help you a lot. Keep your phone away whenever you are solving the questions, and do it from the hard copy. Okay. I have ray optics and semiconductors left. Is it okay to skip it? No. You will be getting the logic gates question. It is 100%. If you will ask me that, sir, what are the topics from where you will tell me that 100% or more than 90% chances are there that a question will come, then it's a logic gate from a semiconductor. You will get a question, 1 or 2 questions from that, right? And ray optics is also very, very important chapter. It's a high weightage chapter. You cannot skip that chapter, and do not dare to skip that chapter. I would be telling you, it's a very simple chapter. Very, very simple chapter. Okay. Now, let's see that how we are going to find out. See, if there is a straight wire carrying a current I at a distance r, if it is making an angle theta 1 here and a theta 2 here, okay, and you need to find out a magnetic field at this point. That magnetic field is mu naught 4 pi r sine theta 1 plus sine theta 2. Okay, this is the formula. And if you modify this, because this is a general formula which I am telling you, because this general formula you can use in any case, and I am telling you that JEE examiners are very creative in asking the questions based on the magnetic field. I do not know how they are getting the creativity, but I am seeing that even in the JEE Advanced, they are very, very creative in making the question on this part. But if you are my student, then you won't be facing any issues, because I'm going to teach you in such a beautiful manner that you'll be able to solve it within few seconds, and you'll be able to crack that pattern. And in exam, you'll be saying that, yes, it's the Manoj sir technique which is going there, that you do not have to see the picture which is examiner wants you to see. You will be seeing the pixels which your Manoj sir is wanting you to see, right? So I am seeing here 3 pixels, right? And I'm telling you that if there is a straight wire, and if this straight wire is carrying a current I at a distance r, there is an angle theta 1, theta 2, and you need to find out the magnetic field at this point. This is the super formula what you must learn, right? And if I'm considering that there is a current carrying wire at a distance r, I'm going at the one side, and this is an infinite wire. This is an infinite wire. So if this theta 1, for this, your theta 1 will become 90 degree and your theta 2 will become 0 degree. So your magnetic field at this point, will become mu naught. Okay, current is also there. Mu naught I divided by 4 pi r. Okay, so this is what you will get. And do you know that due to this wire and this wire, I'll be getting the electric field, the same electric field. So I'll multiply this by 2, plus due to the semicircular wire. Okay, for the semicircular wire, I need to, I'll squeeze this. I'll write the formula for the straight wire as well. I'll write the formula for the circular wire as well. That for the circular wire, if the radius is r and current I is moving, current I is flowing, you need to find out the magnetic field. Okay, the magnetic field is mu naught I divided by 2r. It's mu naught I divided by 2r. And if there is a semicircle, that will become half, right? Because I am getting only the half current. So it's mu naught I divided by 4r. It's 2 into mu naught I. Okay, this is the radius. So this will going to be r, this will going to be r, right? So you can write mu naught I divided by 4 pi r plus mu naught I divided by 4r. So you can take the common thing as mu naught I divided by 4 pi r. So I have to keep pi here plus 2. So does it means that I'm getting this as my answer? How many of you get the approach? Because this question is very simple. I'm not targeting the question, I'm targeting the pattern, I'm targeting the examiner mindset, and I am here to train you to solve the previous year question in such a manner that it is very easy to solve the question which comes in your exam, right? So the approach is very simple. This approach is known as Manoj Kumar sir approach, and it's that do not see the picture which the examiner wants to see the pixel from which this picture is getting created. So here I'm not seeing the picture, I'm seeing the 3 pixels, that the 3 pixels are the straight line and a semicircle. And if I know the formulas, I can combine those formulas to get my answers. How many of you agree with me? Please do let me know in the chat. This energy is very much required when you are attending my lecture, and please do come in the live sessions, because if you are attending live sessions, your life will be created. But if you are thinking or in a dilemma that whether you have to join the classes live or you can watch it later, by increasing the speed to 1.25, 1.5, then it will lead to the procrastination, and procrastination leads to the backlog, and backlog is very dangerous in the last month. You cannot afford the backlog. Sir, how? I have a doubt about semiconductors in. Wow. And today I'm going to block you, beta. I'm going to block you. Is it possible to block here? The spammers are coming, and I'm a big fan of the spammers because these spammers shows that we are doing something great, that ultimately someone is coming here to disturb us, right? So spammers are very important. They are the markers for us that we are doing something better, that someone is scared. Is it clear, my dear? Gokul, you understood? So how do we find the magnetic field by the curve? I told you that due to the straight line and the circular wire, these are the only patterns you will see. Either a straight wire or a circular wire, right? There will be combination. Even I am telling you that here you will be getting the combination. If you ask me that what will be the pixels you will see, the combinations you will be getting a straight wire. I have taken a separate lecture on that. I've already taken a separate lecture on that what are the formulas, what are the patterns that will come, right? This is a special lecture in which I am solving the previous year question, and I'll be giving you the assignment as well. And if you face any issue when you are solving the previous year question or solving the assignment, then you can ask me directly. I am a teacher which is very approachable. You can directly message me and I'll reply you. You won't find such a teacher in online era, right? Now, either you will see a straight wire or a circular loop. So if you are seeing a circular loop, the only formula which you need to remember, is that if at a distance x, you need to find out the I current is flowing, it's mu naught I r square 2 r square plus x square power 3 by 2. And here I've already given you the formulas, right? This is for the straight wire. Now let's move to the next question. This question is very, very easy. Like I am keeping in my mind that it's not always that you will be very happy to solve a question which takes a lot of time, or a very calculative questions one. You also require the questions which can be solved within few seconds, right? So according to that scenario, I'm having this question. This question is from JEE Mains. A loop of flexible wire of irregular shape carrying current is placed in an external magnetic field. Identify the effect of the field on the wire. Okay. A loop of flexible wire of irregular shape carrying a current is placed in an external magnetic field. Identify the effect of the field on the wire. Do let me. Very good. Thank you. Tell me. Gokul knew. They are spammers. They are spammers. They are coming because I have blocked one. Solve this. A loop of flexible wire of irregular shape, when we are keeping this wire in an external magnetic field, the loop assumes circular shape with its plane normal to the field, right? It will take the circular shape, isn't it? Is it okay? Now, let's move to the next question. The next question is similar to the pattern which we have already done. It is similar to the question like here. I told you that multiple times this pattern is getting repeated again and again in JEE, that multiple charges will be provided to you and there will be some condition. You have to find out the force, speed, and there will be some ratios, right? And similar to that, here I'm having a question. Two charges are given here, a proton and an alpha electron having kinetic energy Kp and K alpha respectively, enter into a magnetic field at right angles. The ratio of the radii of trajectory of proton to that of alpha electron is 2:1. The ratio of kinetic energy, basically they are asking that what is the ratio of their kinetic energy. Tell me. Gokul New. What's your real name, Gokul New? Gokul. Gokul, where are you from? Tell me, solve this question. I'm giving, do you want time? I'm giving you 1 minute. Solve this. Star Golu. Hi. There is a golden tip that whenever you see that something is revolving, close your eyes and apply circular motion. Centripetal circular acceleration you can apply, right? If here I'm saying that a proton and the proton and alpha electron having kinetic energy Kp and K alpha respectively enters into a magnetic field at right angles, then I know that they will be moving in a circular path, right? They will be moving in a circular path. There will be some particular velocity, they have their mass. So you can compare that mv square by r is equals to qvb. The force due to magnetic field will be equals to the centripetal force, because the existing forces which is acting towards the center will act like an centripetal force. So this v will be cut, and radius, if I need to find out, that will be mv by qb, right? And there are two particles, serial number, particle, so particle is proton and this is alpha particle. So the charge on this is P. You can consider this charge is 2p, twice positively charged. Okay. And if I need to find out the mass, it's 4m. Okay, find out. Magnetic field will be keeping that magnetic field is same for the proton and alpha electrons, alpha particles. The magnetic field is same. So R1 divided by R2 is equals to 2:1. MVP 4m V alpha charge is 2p, magnetic field is B. So VP is equals to 4V alpha. This is what we are getting. And we have to find out Kp by K alpha. So it will be MP VP square, because half and half will ultimately get cut. It's half M alpha V alpha square. We won't be getting. So this MP proton is M. It's 4m. VP is 4. Are you getting 4:1? How many of you are getting 4:1? How many of you are getting 4:1? Tamil. How many of you are from like Telangana? Whenever you see that an object is moving in a circular way, close your eyes and apply the centripetal force. Whatever the existing forces are there, compare those forces with the centripetal force, like I have done here. I used a centripetal force. I compared the centripetal force with the magnetic force. So it's mv square by r is equals to qvb. Right? From here, I got to know that r is equals to mv by qb. You have to remember this formula directly, but it's a general approach that you can use it while solving the question also. Right? So these are the condition also you must remember. We are here not to solve the question. We are here to learn that what is the pattern at which the JEE examiner is asking questions again and again, so that you won't be able, won't face any issues when you are solving the real exam paper when you sit for your JEE January attempt. Is it clear? You are from AP. Okay. Miru Elanaru. Is it clear, my dear? Shall we move? Got it? Okay. Now, let's move. This question is from JEE Main 2022, and there are two long current carrying conductor are placed parallel to each other, just like here I'm having. Okay, two current carrying conductor are placed parallel to each other at a distance of 8 centimeter between them. So the distance between them is 8 centimeter. The magnitude of magnetic field produced at the midpoint between the two conductors due to the current flowing in them is 300. Okay. See, there was one question in JEE 2025, JEE 2024, that if there are two current carrying conductor, will there be magnetic field at the center point be non-zero value or a zero value? That question was asked in assertion and reasoning. I think that they have mentioned that the magnetic field at the center, at the midpoint, is 0. So student who do not know the real concept, that if I need to find out the magnetic field at this point due to this wire, right, if there is a current, then there will be a magnetic field due to this wire inside. And if I'm thinking that this current is also in the same direction or in the opposite direction, what I need to take? The equal current. Okay. If I'll take this current in the same direction, then what will happen? The magnetic field due to this will be in the opposite direction, right? They will cancel out each other. But what if I am keeping this in the opposite direction? Then the magnetic field due to this I1 is B1, and due to this wire is B2, and this will also be in this direction. See, I told you that JEE examiner are very creative in asking the questions based on this chapter, which is moving charges and magnetism, and you have to be more creative than your examiner. How they can be more creative? They will be asking you multiple times the question. They are twisting these figures, and I told you the approach which is used by my student, the approach is Manoj Kumar sir approach, right? The approach is Manoj Kumar sir approach, and the approach is, do not see the picture which examiner wants you to see the pixels which your Manoj sir wants you to see, right? So if they are saying that there are two parallel conductors, I'm telling you that you do not need to see the two parallel conductors. You have to see one conductor at one time. And if you started to see one conductor at a one time, then you can easily find out what is asked in the question, right? The first thing I can easily identify, that if this conductor is creating a magnetic field at this point, at the midpoint, if this is at 8 centimeter, then this distance must be 4 centimeter and this distance must be 4 centimeter, right? So due to this I1, there must be a magnetic field which is B1, and the direction of this magnetic field is inside the plane. And if I keep this wire in the same direction, then what will happen? It will generate the magnetic field at this point in the opposite direction. And if the magnetic fields are in opposite direction, then I won't be getting the magnetic field, net magnetic field, because at that condition the net magnetic field must be 0. But here they have mentioned that the net magnetic field is non-zero, and they have also given us the value. It shows that the current flowing in both the wire are in the opposite direction. That means that this option is not correct. And when this option is not correct, then you are left with 3 options, right? Sometimes if you are lucky, you can cut down 2 options directly by thinking this, right? So now we have to solve it. If I need to find out the net magnetic field, I am telling you that you do not need to see the picture, you have to see the pixel. And if you are seeing the pixel, you need to find out B net. So what is B net here? What is B net here? These can be easily be add up, right? And I'm thinking that it's a long wire, so it's an infinite wire. So the formula is mu naught I divided by 2 pi r. 2 and 2 will, shall I? Okay. Okay, I'll keep this thing. And the value is 3 micro Tesla. Okay. And solve this to get the answer, to get the value of I. Solve this. We need to solve this to get the value of I. 2 mu naught I. R is given to us. R is 4 into 10 to the power minus 2. I'm multiplying it by 2 and 2 so that I'll get 4 pi here. Okay. And the value of R is 4 into 10 to the power minus 2. It's micro Tesla, so it will be 10 to the power of minus 6. 10 to the power minus 7. So I is equals to 60 ampere. Are you getting this? I is equals to 60 ampere. 60 ampere in the opposite. Ignore these negative comments. What they are telling. Sir, good evening. Please, sir, answer my question. I studied 10 chapters in PCM. And who are sending negative comments? Ankit Singh. Okay. So we are getting spammers. Spammers are very important. Do you know that spammers are very, very important? Why spammers are very important? Because it shows that you are doing something great, that your competitors are sending the spammers. Because why they are feeling jealous? Either they are not the students or they want to disturb me. I'm not getting disturbed. Samhita Agash. Is it clear, my dear? Are you getting this? Please let me know. Are you getting this? Wait. I have put an extra 2 here. This won't come. I have keeping to 300. 30 ampere. Answer is B. Okay, so basically I have to make this as 4 pi. So I need to multiply 2, and if I multiply this 2, this will become 4 pi, right? So I have added the extra 2. That's why I removed that 2. I hope that that thing is clear. So the answer is 30 ampere in the opposite direction. So let's move to the next question. That is the next question. In this, there is a question from JEE Main 2022. A charged particle is moving in a uniform magnetic field, and this time the magnetic field is given in a vector format. This time the magnetic field is given in a vector format. So magnetic field is 2i cap plus 3j cap if it has an acceleration of So acceleration is also given to you, alpha I cap minus of 4 j cap. Then the value of alpha you need to find out. Please answer my question. Anand sir, good evening. Please answer my question. I studied 10 chapters in PCM. Can I score 96 percentile on upper attempt starting from now? Please tell me. Yes, obviously you can. Even if you can score 100 percentile. See, if you ask me, sir, can I go to Delhi within few hours? Yes, you can. But it particularly depends that where are you now. It's like when you use the Google map, you have to put two conditions: your current location and your desired location, right? Then Google will tell you that yes, it will take this much of time, and by seeing that will tell you that this much time you will take. Also, the Google will tell you that by if you go by walking, then this much time you will take. If you go by public transport, then this much time. If you go by two-wheeler, four-wheelers, then this much, right? If you want to achieve a particular target, you have to do the practice in such a manner, right? If you're targeting for the April attempt and you are thinking in January, there are still 4 months left. It is very long journey. Do not plan for a long journey. Ultimately, if when we are doing the planning for a very long duration, we overestimate it, and when we are solving it, when we are planning it for the smaller duration, we are generally under plan it. So I want you to please focus on the January attempt, because in January attempt, even if you score less marks, your percentile will be very high. And this is from my experience. I'm having a decade years of experience, and I have taught multiple students, and I have seen that in January attempt they are getting a very good rank. And if you really are serious aspirant, I have seen that they are doing great in January attempt, right? Because if you feel that January attempt is not for you, you will be giving your 100% effort in April attempt, you will be you do not provide anything to this January attempt. Board level, Ankit Singh. Now I think that it's time to go. I think that it's time to go. Spammers out of the class, because I do not want to disturb the whole class. And you are blocked from the Rankplus channel. Spammers are required, but we do not want spammers to disturb our class. I hope that this thing is clear, right? I told you that in physics, ultimately the two skills you require. The first one is the observation skills, and the second one is the comparative skills, that you have to compare multiple times. And as a student, you must know that force is force. For a single charge particle, the force formula is q v cross b, right? Also, we know that the second law of motion says that force is equals to mass into acceleration. Isn't it? Force is equals to mass into acceleration. And to get the value of acceleration, you can get its q by v. V cross v, right? And now you have to find out that what is the value of alpha. So what value you are getting? Tell me. What value you are getting? 6. Divyanshnath, option B. I think Anand, your doubt is clear. Is it clear, my dear? Is it clear? So basically, whenever we are seeing a cross product here, we know that these are perpendicular, and if these are perpendicular, the acceleration and these are perpendicular, so I can use the dot product. So if I'll multiply this 2 alpha minus 12 is equals to 0. So alpha will be 12 by 2. I'll get the answer as 6. So many students gave the correct answer. Very good. Now let's move to the next question. This question is from JEE Main 2022. It says that Bx and By are the magnetic field at the center of two coils X and Y, each carrying equal current. If X has 200 turns and 20 centimeter radius and Y has 400 turns and 40 centimeter radius, the ratio of Bx and By is. Okay, it's very simple. You know what is the formula? If this is a coil and Bx is the magnetic field at the center, so for the center it's very easy. The magnetic field is mu naught I divided by 2r. And if there is number of turns, I'll put n here. You need to find out two ratios, Bx divided by By. The radius are different. Currents, I think they have equal currents. So you do not need to consider the current. You do not need to consider the mu naught here. So these two conditions are constant in this. So I can say that it will be nx divided by rx is equals to ny divided by ry, right? Solve this to get the required answer. It will become nx divided by rx into ry divided by ny. So number of x turn is 200. Number of y turn is 400. Ry is the radius of y. It's 20 centimeter. Okay, both of them are having the same radius. So that will be 20. Okay, I do not need to take that also. So I'll be getting 2, 1 is to 2. 1 is to 2 is my answer. Are you getting B? How many of you are getting B? B as answer. There are so many. See how many IDs this guy is having. He wants to get blocked from all the IDs. Wow. And today I'll do this liberation work. Today I got a chance. The last year I need to. Now let's move to the next question. This is the next question. In this question from JEE Main 2022, there are two concentric circular loops of radius r1 30 centimeter and radius r2 50 centimeter are placed in xy plane as shown in the figure. A current I is equals to 7 ampere is flowing through them in the direction as shown in the figure. Okay. And the net magnetic field of this system of circular loop is approximately. So I have already shown you that how we are going to solve the questions where we have to find out the magnetic field at the center when a current loop is given. We have now we know the formula, right? I hope that even if you do not know the formula, we have done multiple questions. And if you are noting it, you got the formula, right? Now you have to solve it on your own and do let me know that what is the answer. I'm giving you 1 minute. See, it's not important to see the solution. It's important that you are trying to solve it now so that your brain thinks in a different patterns, that if you see ultimately a different questions, then your brain responses to it, right? This is kind of a stimulus which is you are giving to your brain. So tell me, Arshit Gupta, B. Yeah. Okay, let's see. See, if I have to solve this question and if I'll be sitting in the exam, then consider I generally solve it without using my pen. So let me tell you that if there is an xy plane, this is x, this is y, this is z axis, this is O. These two coils are basically placed in xy plane. In the inner circle, we have a current I. Okay, both of them, through both of them, the current I is flowing. This is R1 radius and this is R2 radius. It is going forward. Right? And now you have to find out that the net magnetic field, the net magnetic moment of this system. You know what is magnetic moment? Net magnetic moment. The net magnetic moment is I A. Current into area. Okay. Current into area we can use. Are you getting? The Harshit Gupta. Gokul New, have you done this question? Have you done? Tell me. So calculate this and do let me know that. See, I can cancel some of the options because IA area vector IA. This current is in the opposite direction. See, I know that magnetic moment is IA, and if there is internal, I'm considering the internal circle which is of radius R1, there will be magnetic moment M1. The value is IA, right? So the direction will be in this direction. And for the external circle or the external loop, the radius is R2. And when the radius is R2, the magnetic moment is here. Now you tell me when I'm taking the external circle which is having the radius R2, the area is bigger, right? When the area is bigger, the magnetic moment value is bigger. And when I'm calculating the net magnetic moment, it will come out to be negative. And when it's coming out to be negative, this direction is K positive and this direction is K negative. Right? So I'm getting that my this M2 magnetic moment is greater than M1. So my value can't be positive. So these two values can't be my answer. So either I'll get this one or either I'll get this one. So you can solve it. Trying, sir, not getting Gokul? Okay. Because these are some questions which you have to ultimately solve. Okay. Now, so this is pi a. If I need to find out mnet, so mnet will be I because I is same pi R2 square minus R1 square. So I is 7, pi is 21 by 7, R2 is 0.5 square minus 0.3 square. Okay. Now this will be cut 22. You know that there is a formula a square minus b square, which is a plus b, a minus b. So I am using the same formula. 0.5 plus 0.3, 0.8, and 0.5 minus 0.3, 0.2. So it's 22, a to the 16 divided by 100. I think that is coming in the decimal. 88 divided by 25. 3.5. B option. Are you getting the same answer? Please do let me know. 3 point approx. Yes. B. No, I do not understand it why they have given such a value. They are like giving the option in a numerical terms and integer terms, like it's minus 7 by 2, 7. And answer is getting in the decimals. So here a velocity selector consists of electric field and the magnetic field. So electric field and magnetic field is given. Now, first of all, I'll discuss this thing, that whenever you are solving any question, use this approach when you are solving the mock paper, use this approach when you are solving the practice papers, that first of all see all the options and guess that what could be the answer, right? Here, that before even starting the calculation, the real calculation, I have marked that these two can't be my answer, right? Before starting the actual solution, I have marked that these two can't be my answer. My answer will be from these two. And if you do multiple practice, then you can easily guess that what could be my answer. Is it clear, my dear? Is it clear? Now let's move to the next question. So next question is here. I'm giving you 1 minute, as we are giving you in every question. So a velocity selector consists of electric field E vector, it's E k cap, and the magnetic field is B j cap, with magnitude is given to you. The value of E required for an electron of energy this much moving with along the positive axis to pass undeflected is. Okay. To go undeflected, basically what is required? What is required? QE, the forces must be balanced, right? The net force must be 0. Solve this. 190 Diveshnath, very fast. Very fast, Diveshnath. See, to get the answer, we know that when the energy is given to us, energy you can use half mv square, right? From here you can find out 728 electron volt half mass of electron and v square. From here you can get the value of v, and there is also a formula, E is equals to VB. If you multiply this with the value of B, you will get the answer. So my main thing is to get the value of V here. So it's 728. You have to change this electron volt into the joules. So it's 1.6 into 10 to the power of minus 19. E equals to half. The mass of electron is 9.1 into 10 to the power minus 31 V square. 728 multiplied by 2 into 1.6 into 10 to the power minus 19 divided by 9.1 10 to the power minus 31 is equals to V. You have to take the root and ultimately you have to get the answer, right? So very huge calculation. I can use the guesswork, but I'm not using it. You guys can do your calculation on your own. So velocity we will get 16 multiply 1 2 3 4 5 6 10 to the power of 6. Okay, and if you put the value here, the E is equals to 16 into 10 to the power of 6 into 7 into 12 into 10 to the power of minus 3. So you will get 192 kilowatt. K. Are you getting this? Very good, Divesh. This is the correct answer. Very good. Let's move. Okay. This is one of my favorite question. I generally take this question in my classes as well when I used to teach a long-term course. So in this question, as shown in the figure, a metallic rod is there of linear density basically is provided to you. What does linear density means? Linear density means it is it is basically the value of mass per unit length. Is lying on a horizontal smooth inclined plane which makes an angle of 45 degree here. With the horizontal, the minimum current flowing in the rod required to keep it stationary when 0.15 Tesla magnetic field is acting on it in the vertical upward direction. Okay, so let me draw the diagram and you also have to visualize this thing. I think that I'm able to draw the diagram so that you can have the feel how it looks. There we have a wire. Okay. Now this wire may be having its mass, and you know that anything that is having a mass and we are keeping that thing at an inclined surface, there will be a downward force which is equals to mg sine theta. How many of you agree with this? Right? There will be a downward force which is acting in this mg sine theta whenever we are keeping any object in the inclined phase. Now there is the magnetic field of 0.15 Tesla. Magnetic field is acting in the vertical upward direction. So your magnetic field is moving in this direction. Okay. Now think of like this. If I am having an inclined plane, this angle is 45 degree, this is 90 degree, this is 45 degree. So this will also become 45 degree, right? This will also become 45 degree, and this is your magnetic field. And if you want to resolve this magnetic field in this direction, that will be B cos 45 degree. Means the ratio B cos 45. It will be B cos 45 degree. Are you getting this? And if I am keeping a mass here, there will be a downward value which is equals to mg sine 45 degree. Are you getting that thing? Are you getting that? Right? I hope that this thing is clear. Now, if this thing is clear, so there will be an mg sine theta, and here I'll be having BIL cos theta. And these two values must be equal if we want that this current carrying rod must be there and it will remain stationary. So I can use as the angles are same, so I can say that mg is equals to BIL. I need to find out the magnetic field acting in the upward direction. I need to find out the current. So the value of current is m by L G divided by B, and m by L is given to you. Linear mass density is given to you. It's 0.45. The value of G is 10. I'll take, and it's 0.15 magnetic field values. 30 ampere. Are you getting? Are you getting 30 ampere? Diagram is very tricky to visualize. No, you have to visualize it, because like if you have done it 1 or 2 times, you will be able to visualize this, that what is happening here, right? Basically force is force. I'm telling you that ultimately you have to compare things with another things, right? And force will be force. It doesn't matter that the force is equals to mass into acceleration, or it is a magnetic force. Here, if the magnetic field is going in the upward direction, you have to resolve this magnetic field in this direction. And if there is a current I, then due to a current carrying conductor, you know that which type of magnetic force. There is only one formula which you have studied in this chapter. There is only one formula which you have studied in this chapter, that due to a current carrying conductor, the magnetic field is BIL sine theta. You tell me that if you have studied any other formula. See, we have to be constrained. When we are constrained and we only think in terms of the syllabus, we will be able to do the questions which others won't be able to do. So this is a bonus question if you know how to solve it. but it will become very difficult for the students who feel that the diagram is very tricky, who feels that this question is very difficult, because sometimes students just see the diagram and they feel that, oh, what they have asked, moving charges and magnetism, it's a very difficult topic, because we have to be very good at doing the pixel and picture things. What is picture and pixel things? That the examiner is very creative in creating the questions from moving charges and magnetism. Basically what they do is they they create a very tough situation, but if you divide that tough situation into a very doable parts, you'll be able to solve it within few seconds, right? So I'm explaining you again that there was some inclined plane, and due to that inclined plane, if there is any mass, we know that mass gravity always acts downward, so that will be the mg, right? That will be my mg, and this will be my 90 minus theta, or you can say that you will have theta here. So this component is mg cos theta, and this component is mg sin theta. There are so many students here who do not know that how I have resolved this. That due to the mass, this will be my resolution of the forces, right? And for the gravitational part, it was given that the magnetic field is moving in the upward direction, and when the magnetic field is moving in the upward direction, this angle was given to you, right? And you can resolve this magnetic field wherever you want. If you want to resolve it here, it will be b cos theta. If you want to resolve it here, it will be b sin theta. It's up to you. Next, electrostatic you want? Electrostatic, I have already taken the one-shot video on the electrostatic. I'll be taking the either semiconductor or a nuclear, because these are high weightage chapters, right? So there was demand from students who want me to take this chapter, moving charges and magnetism. That's why I have taken this. Now solve this question. A triangular shaped wire carrying a current 10 ampere current is placed in a uniform. So I told you that in these types of question, you have to, what is the approach? You have to use Manoj sir approach. And what is my approach? What is the MKS approach here? You do not need to see the picture. I am prohibiting you to see the picture. I am telling you that you need to see the pixels. You have to be very good at seeing the pixels. Once you are very good at seeing the pixels, you will see that these types of questions are very easy. Now, if you are a serious aspirant, you can divide this question into how many parts? 1, 2, 3, 4. There are 4 parts. The first one is the straight wire. Second one, third one, and the fourth one, right? So first of all, let's see that what they are asking. It's not like that we are solving it, we are making it very difficult if we need to find out the magnetic field at the center. But this question is very easy. JEE Mains, this question was asked in JEE Main 2022. A triangular shaped wire carrying a current of 10 ampere current is placed in a uniform magnetic field of 0.5 Tesla as shown in the figure. The magnetic force on segment CD, this is the segment where you have to calculate. This is the segment CD. Okay, a uniform magnetic field of 0.5 Tesla as shown in the figure. The magnetic force on segment CD is, okay, I hope that you can easily find out. First of all, what is the magnetic force? I told you that there is only one formula to get the value of magnetic force. It's BL It's BIL sine theta, right? So use this and find out. I'm giving you 1 minute. As I have explained you, you have already taken 1 minute. Option C, Divyesh Nath. K Kumar, hi. Tell me. One student have already done. Divyesh Nath. 26 second. See, this question is very, very simple. Shall I give you more time? 18-15 seconds left. See, I have given you the hint. It's just you have to use the Bill sine theta. So magnetic field is already provided to you. It's zero point 0.5. Magnetic field is already provided to you. Current is also provided to you 10. And this wire is making, right? If you see the pattern here, 5, 5, 5, isn't it a equilateral triangle? So the angle will be 60 degree. So I can take sine 60 degree. BIL. L also I have to take on 5. And sine 60 degree is root 3 by 2. It's 5. So it's 25, 12.5 into 1.73 for the root 3. Okay, it's centimeter. That's why I think that why we are not getting 10 to the power minus 2 also you need to take consider. So it's 0.125 into 1.73. Multiply this. These are very calculative questions. 1.25. Hi Tulsi Kumar. I hope. Is I'm audible? Yes. So it's done. How many of you got the correct answer? Hilesh Sahu, I think that was the previous. Divesh, no. Divesh, Divesh Nath got the answer and he's saying that it's B. Okay, let's see that whether the question is correct or not. There might be the mistake. The magnetic field at the center of a current carrying conductor of circular loop is B1. The magnetic field at a distance of 3 times radius of a given circular loop from the center on its axis is B2. Okay. Then you have to find out that what is the value of B1 and B2. This is a standard question which you can expect, and when these types of questions comes, we generally says that the paper is very easy. If I'm considering that the radius is r and at the center I need to find out the magnetic field, the magnetic field at the center is mu naught I divided by 2r, right? This is the value of the magnetic field. If I'm going at a distance x, which is equals to 3r this times, because it is giving in the question that the magnetic field at a distance of 3 times radius of the given circular loop from the center of the axis, I am having the magnetic field as B2. The value of this is mu naught I r square divided by 2 r square plus x square, and the value is 3 by 2 here, right? And ultimately you have to find out the ratio of B1 divided by B2, right? And if I need to find out the ratio, it will be mu naught I divided by 2r. It's mu naught I r square divided by 2 r square plus x square 3 by 2. You can cut this mu naught I. It's 2 will be cut. It will be r square divided by r square plus 3r square power 3 by 2, right? It's 1 by r square plus 3r square 3 by 2. So B1 divided by B2 is equals to 1 by r multiply r square plus 3 9 10 10 r square power 3 by 2 you will get 10 to the power of 3 by 2 into r cube. So it will be cut. Ultimately, only 10 to the power of 3 by 2 is left. Are you getting the same answer? Only this is left. 10 to the power of 3 by 2. And yes, this is what we are getting. Are you getting another? Are you getting another? We can simplify. No, we can, but we are not getting the same answer, right? We're not getting the answer. This is what we are getting. Are you all getting this? Are you all getting this thing? Divesh Nath. Divesh Nath is also getting the same. Okay, I think that there is some mistake in the question. E. None of these. Okay. So answer is not matching. It's none of these. Let's move to the next question. Okay, this question is from JEE Main 2022, and as I told you that first of all, before starting the actual calculation, you have to see that what are the options given to you. Like here, it's directed towards wire S, directed towards X, towards wire X. So 3 times they are telling you that it's towards wire X, towards wire X, towards wire X, right? And value is also given to you. It's 1.2, 10 to the power minus 5, 10 to the power minus 4, 10 to the power minus 4, 1.2 is there, right? So there are some short tukka tricks, you will say, that how to guess the correct answer. So when we have to guess the correct answer, we generally see that what matches a lot. But this kind of guesswork is not required in these types of simple questions. In this question, basically a wire X is there of length 50 centimeter carrying a current of 2 ampere is placed parallel to the long wire Y, and which is having a length of 5 meter. Okay. So this is having 50 centimeter. This L1 is 50 centimeter. This L2 is 5 meter. Put this as 0.5 meter. Okay, it's 10 times bigger. This is carrying a current I2. This is I1. The distance between the two wire is 5 centimeter and current flow in the same direction. The force acting on the wire Y is. So you just need to find out the force. Tell me how you can find it. I'm giving you 1 minute. Think about this. There is only one formula which you know to get the value of force, and that formula is BIL. But here we need to use this magnetic field due to the other wire, due to the straight wire, that is equals to mu naught I divided by 2 pi r. Okay, so basically you have to combine these two formulas to get the correct answer. And if you know the formula, it comes out to be mu I1 I2 L divided by 2 pi r, right? You can use this formula to get the answer. Do let me know what is the value you are getting. Option A, Divesh. So we get the answer matched. Okay, is it like that? Is it like that? We have to take the root 3 here. But as per this question, the answer is not matching. It's like that we have to modify the question, right? We won't be modifying any question. Even it can happen in your JEE exam. Try to solve that question one time, right? Try to solve that question one time, and if you are not getting the correct answer, leave it. Again, if you have time, then you can go for the second attempt. But even if in the second attempt you are not getting it, do not try to modify that question, right? Because ultimately, if that question was wrong, you will be getting a free marks. You have to do not consider that thing. Tell me. Yes, typing error. It can happen any time. Diveshnath, where are you from? See, first of all, as I told you that always I see the options before starting the actual calculation. Here I am seeing that both the wires are carrying current in the same direction. So if they are carrying current in the same direction, they will attract each other, right? If they are attracting each other, then I know that my answer won't be the option. This option can't be my answer, right? It can't go away from this wire, right? Now, if this can't be my answer, you can calculate. I multiply this by 2 by 2, so I'll get mu naught by 4 pi here. To make the calculation easy, I1, I2, L, six. One 1.2. Is it coming to be 1.2 into 10 to the power of minus 4? Is it minus 4 or minus 5? Minus 5. Is it A option? Bengaluru. Yes, option number A is coming. It's correct. Yes, option number A is coming. It's correct. Now, let's move to the next question. This question is from JEE Main 2022. So, I have told you that multiple times this is the favorite pattern of JEE. They will be providing you multiple charges with some multiple datas, and you have to find out the ratio. Like in this question, two charged particles having the same kinetic energy are allowed to pass through a uniform magnetic field perpendicular to the direction of the motion if the ratio of the radii of their circular path is 6 is to 5 and their respective masses is 9 by 4. You need to calculate the ratio of their charges. Now this time their kinetic energy are same. Tell me how you are going to approach. Length is 0.5. Okay. In meter, always remember that you have to take the values in meter. It's Manoj Kumar sir. It's Manoj Kumar sir. You have to follow me. You have to keep you. It's the MKS unit by default. By default, you have to follow me. Right? Like it's Manoj Kumar sir. Your length must be in meter, weight must be in kg, and time must be in second. Now, I haven't started the timer. Let me start the timer. Find it, find it. Find it. Yes, yes. Because if when you are calculating the force, no, value of y, BIL, the length should be of the same wire. Length of the same wire, the magnetic field is due to the other wire. Current is also for the same wire. Okay, Divesh Nath. Divesh Nath have solved this question. Anyone? See, there is a direct formula for this. They're asking us Q1 by Q2. It's M1 by M2, R2 by R1, 2 by 3, 5 by 6. Oh, M1 by M2 is 3, 3 by 2. It's 5 by 6. We'll be getting 5 by 4. So option B. Are you getting option B? Yes. Option B is correct. Gokul, have you got the correct answer? We got the correct answer. Shall we move? Let's move to the next part. The next question is the magnetic moment of an electron E revolving in an orbit around the nucleus with an orbital angular momentum is what? So it's a conceptual question. The answer is this one. Let's move to the next part. So it is similar to the question which we have done earlier. The electric current in a circular wire of 2 turns produces a magnetic field, magnetic induction B1 at its center. The coil is unwound and is rewound into a circular coil of 5 turns, and the same current produces a magnetic induction B2 at its center. The ratio of V2 by V1 you have to find out. Tell me, can you able to solve this question? Formula is very simple. Divesh, Gokul, will you be able to solve it? Will need some time. Okay. There is a shortcut trick for that. There is a shortcut trick for that, because if it has come in your JEE exam, and there are so many shortcut tricks which I'm creating, because in this electric current in a circular coil of 2 turns, a magnetic, there is only 2 turns. Tell me the wire is same. Yes. Basically what happens is you just need to square it. You just need to square it. N2 by N1. So N2 is 5. So it's 25 by 4. Our answer will become 25 by 4. This is a shortcut trick which you can use. If we are not changing the wire, we are just rewounding it. Then you can use this shortcut trick. This is the shortcut trick which you can use to get the answer. And remember that if it was there in your previous year question, it can be there in your JEE 2025 exam as well. Now, this question is from JEE Main 2022. Here, an electron of energy 0.1 kilo electron volt moves at right angle to the Earth's magnetic field of this much. The frequency of, okay, the Earth magnetic field is not there in the syllabus now. So this question needs to be deleted. It's from the old syllabus. Okay, now let me know. This question is from JEE Main 2022. The question is, there is some assertion and reason. Tell me. In an uniform magnetic field, speed and energy remains the same for magnetic charge particle. Moving charge particle experiences magnetic force perpendicular to its direction of motion. Hi, good evening, JEE, GG. Or I would be saying JEE, JEE. What is the correct pronunciation which you want me to say? Tell me, tell me, tell me, tell me. Tell me fast. Let what will be the answer. In an uniform magnetic field, speed and energy remains the same for the moving charged particles. Yes. Moving charge particle experiences magnetic force perpendicular to the direction of motion. Yes. So both of them are correct. So can you tell that the reason is the correct explanation of assertion, or it is not the correct explanation of the assertion? These can't be my answer. Please do let me know that either A or B will be my answer. Option B. See, why when something is moving in a circular orbit, right? Moving charge particle experience a magnetic force perpendicular to its direction. As the magnetic force is acting in perpendicular direction, it is not changing, it is not providing any acceleration, right? But if there is an electrical field provides the force in the force for the translational motion, and due to that there must be some acceleration. So this reason is also correct. If we are considering that thing, this reason is also correct. Now, because if there is some acceleration, then what will happen? Its speed will get increased, and if that speed will get increased, its energy, the kinetic energy, will also get increased. Are you able to? If there is an electrical field and there is a charge, so electrical field force is equals to QE, that provides the acceleration. But if I am considering the magnetic field, that magnetic field provides a circular rotation. So as the rotation is circular, it do not changes the value of the speed. So next question is, the magnetic field at the center of a circular coil of radius r due to the current I flowing through it is B. The magnetic field at a point along the axis at a distance r by 2 from the center is, okay, that's a very easy peasy question, and I hope that you will be able to solve it within 1 minute. How? We know that the magnetic field at the center of the circular coil of radius r, current I is flowing through it, it's B, and you need to find out magnetic field at a distance r by 2. So x is equals to r by 2. So at this point you need to find out the magnetic field. So your magnetic field is mu naught I r square divided by 2 r square plus x square 3 by 2. And this is B dash. This B value is mu naught I divided by 2r. Put xs r by 2. R cube to 8 cube. 5 to the power 3 by 2. It will become r cube. And this will become 8. So it's mu naught I divided by r. So this b dash will become 2b into 4 by 5 to the power 3 by 2. So b dash is e b8 5 to the power 3 by 2. Can keep this. Okay, I got the answer. This will be my answer. Are you getting this answer? C. Yes. Gokul. I hope that now you'll be able to solve these types of questions very easily, because there is a pattern of questions which is coming. Just you need to know the correct formula and the correct approach. And the approach is Manoj sir approach, that you do not have to see the picture, you have to see the pixels, right? Let's move to the next question. In this, a long solenoid carrying a current produces a magnetic field B along its axis if the current is doubled. Okay, if the current is doubled, we know that magnetic field is mu naught Ni. It's saying if the current is doubled and the number of turns per centimeter is halved. Okay, your number of turns is halved. The new value of magnetic field, what it will be? What it will be? It's the counter thing, right? They are increasing the number of current. It's doubling the current, but it's decreasing the similar amount of the number of turns. So it will be B. Next. Okay. So this is based on galvanometer. So 72 ohm galvanometer is shunted by a resistance of 8 ohm. The percentage of the total current which passes through the galvanometer is what? So do you know that's how we are going to solve the galvanometer type question? There is a galvanometer. The resistance of galvanometer is Rg. And if I need to extend the value of galvanometer wants its own current, Ig. If I want to increase the value of current, then that current must passes through the shunt wire, right? This current must be passes through a shunt wire, and the shunt wire value is S. And this is I minus of Ig. So you have Ig Rg is equals to I minus Ig, and there is a value of shunt. Use this equation to get the answer, and do let me know that what is the answer you are getting. I'm giving you 1 minute for this question. Option number A you are getting? Is this for this question or for the previous question? I think that previous question you are talking about. For previous question. Wait a minute. I need to get my camera setting changed. Only 8% battery left. Find out the answer. Gokul, option B for what? For this? Yes, option B is correct. 10%. Diveshnath, option B. Okay. Yes, option B is correct. You both have got the correct answer. Let's move. Okay. Now, a proton and an alpha particle of the same velocity enters in a uniform magnetic field which is acting perpendicular to the direction of motion. The ratio of the radii of the circular part described by the alpha particle to the it is similar to the question which we have done earlier, right? It is similar question which we have done earlier, that there are some conditions given to you for the charged particle and you have to find out the ratio. Now, in this question, the two parallel long wires are kept this much of distance. Each is carrying a current of x ampere in the same direction. If the force of attraction between them is this thing, you have to find out the value of x. We have already done this type of question, right? I'm telling you that if you're solving the previous year questions, ultimately for 1 or 2 years, you'll find that whenever you are finding the next question, it is similar to the previous question. And that is what I wanted you to achieve. To familiarize with the previous year question. Now, let's solve this graph question. Let's solve this graph question. Tell me, which graph is correct? An infinitely long yellow conducting cylinder with radius r carries a uniform current along its surface. Choose the correct representation of the magnetic field as a function of radial distance r from the axis. Okay. Now inside, do we have? See, I'm having my own approach of solving the graph questions. My approach is, think of one statement which I am saying to you. If you do not have any plan, search for the extreme ends. What does it mean when I'm saying the extreme ends? You have to see that what happens in the starting, what happens in the beginning, like what happens in the starting, what happens in the end, and what is there in the middle path. So I know that the wire do not have the magnetic field when it's inside. Yes, like there are some derivation will always be there. Are you getting that what I am telling you? That we know that in the inside wire we do not have the magnetic field. Now, these are some numerical type questions which you have to do. Like a closed wounded circular coil of radius this much produces magnetic field, and the current through the coil is this much, because recently we have two sections, section A and section B. Section A, you will be getting 20 questions. You have to select the correct options, but in section B you not being provided by any options. You have to solve it, right? So you must have the habit to solve it. So these are the questions which I am providing you for the homework. This is homework. These numerical types questions are homework, and this is also an homework, very special question. I hope that now you will be able to solve it. This is from JEE Main 2023. I'm ending up this session. A very happy new year to all of my future engineers. I hope that you all will be getting the college and the branch which you have dreamed of, and your all dreams will come true in this 2025 new year which is coming. Okay, and I want you to please like this session and share this session with your friends if you want more sessions like this, and do let me know in the comments that what topic do you want me to take in the next session. So thank you Gokul, Diveshnath, for joining this, right? And I'm telling you that if we will stay there together, we can do anything which you haven't imagined, right? So We will meet again in the next class, and if you haven't subscribed to our YouTube channel, please do subscribe, and if you are not following us on our Telegram group, do follow us on our Telegram group. And if you face any issues, if you face any issues while solving the questions, you can directly send me message on the Telegram or the Instagram. We'll meet again. Till then, bye bye.